So let's go through these, find out what are equal to each other. If you want to list them all, you can, but I'm just going to just show you. Angle 1 is equal to angle 5, but I want you to give me reasons. Why does 1 equal 5? Corresponding angles are congruent. That's what you write down. You write down corresponding angles are congruent or equal. All right, tell me what else is equal to angle 1. Angle 4. Give me a reason why angle 1. That's right, because vertical angles are equal or congruent. Right, okay, that's the reason. Do you hear me? Vertical angles are congruent. You don't just say because they're vertical angles, you say because vertical angles are congruent. Right? Give me something else that's all equal to angle 1. Okay, 1. Why is 1 and 8 equal to each other? Because they're alternate exterior angles. That's right. So 1 equals 8 because they're alternate exterior angles. Are there any other angles that equal angle 1 here? No, there's not. That's it. Okay. What about angle 2? Let's go to angle 2. We'll put 2 arcs around this so we know the difference between them. All right, so 2 and 3. Give me a reason. Vertical angles are congruent. Okay, what else? 2 and 6. Why are 2 and 6? Corresponding angles are congruent. Okay, 2 and 7. Why? Alternate exterior angles are congruent. You with me on that? Really, all you needed to know, you didn't even have to know this theorem about alternate interior angles. You didn't have to know this one. You didn't even have to, well, yeah, you probably didn't even have to know this, because watch. If I know, and this is why this is a postulate, because these can be all proven. These are all theorems right here. Let me write that word down. Everything except for the corresponding angles are all things that we call theorems. And what do we say about a theorem? A theorem can be proven, okay? You can prove a theorem. You don't prove a postulate, you can prove a theorem. Let me show you why. We just know that 1 and 5 are equal because they told us, right? Because they told us corresponding angles were equal. Watch. If 1 equals 5, we already knew that 1 equals 4. Without using any of these theorems right here, without using those at all, why does 1 equal 4? Something we've already talked about. Vertical angles, right? Vertical angles are congruent to each other. That's something that we already knew. So 1 equals 4. And then 4 equals what? 8 for what reason? Why does 4 equal 8? Because corresponding angles are congruent, correct? So watch. 1 equals 4. 4 equals 8. 8 equals what? 5. All right. So really the only thing we used are what? Vertical angles and corresponding angles. We didn't use any of this, did we, to get those angles equal to each other. So we didn't really even need all these things. But these things are nice to see. It's nice to see that direct relationship so you don't have to skip over all the place to find out which ones are equal. But you know what you can also do? Look at all the obtuse angles. 1, 4, 5, 8. What's true about all the obtuse angles? They're all what? They're all equal to each other, aren't they? All the obtuses? Look, 1, 4, 5, and 8. They're all equal to each other. What about all the acute angles? 2, 3, 6, and 7. What's true about all the acute angles? They're all equal to each other, right? So really, all you got to do is look at it and say, okay, if I have this situation, if I have 2 parallel lines cut by a transversal, guess what? All the obtuse angles are going to be the same, and what else? All the acute angles are going to be the same, all right? You don't even have to go through all this stuff. Now, what's true about 4 and 6? Watch this. Let me show you. This is like a little mini proof, all right? Your first one you've ever seen. Let's try to show why 4 and 6 are supplementary. Let's do this. Angle 3 equals angle 6, doesn't it? Do you agree? What's the reason? Why does 3 equal 6? Because alternate interior angles are congruent, okay? So 3 equals 6. Tell me something about 3 and 4, though. Yeah, why are they supplementary? Because they form a linear pair, okay? So what I can do is I can say this. Since they're supplementary, I can say, watch, angle 3 plus what? Angle 4 equals 180 degrees. Would you agree? Now, what am I trying to show? I'm trying to show that 4 and 6 are actually supplementary. Can I take this information to get 4 and 6 supplementary? Look what I can do. Since 3 and 6 are exactly the same thing, what can I do? Replace this, or this is called substitution. You follow me? I'm taking a 6, and what am I doing? I'm putting it in its place. I'm substituting a 6, angle 6, in for angle 3. So watch, I can go angle 6 plus what? Angle 4 equals what? 180. So look, 6 and 4 add up to 180. So what must be true about 6 and 4 then? They must be what? Supplementary. Do you see it? We actually just proved it. That was a proof. We just proved that consecutive interior angles are supplementary. And we did it with stuff that we already knew before. All right? Isn't that interesting? So that's a proof. And I didn't write down the reasons, but I gave the reasons. We talked about the reasons for all that stuff being true. Okay? Something you can prove. We probably won't prove it. In fact, Pythagorean theorem was named after Pythagoras because he was the one that gave it a nice formal proof. He didn't really come up with it, but he actually came up with a proof for it. And you're right, Pythagorean theorem can be proven, and I don't think we're going to prove it in here, but I think it might be in the book somewhere if you want to see the proof. Okay. All right. Let's do one more thing. Tell you what. Let's pause this. I'm going to do an example and show you one more theorem and we'll be done. So here's an example. This was taken right from the book on 180. So let's do this. Let's say they number them and stuff, but I'm just going to write them in there. It says this angle is 2x minus 17. All right, so we'll just say this angle right here is 2x minus 17, and this angle up here is 85 degrees. This is really simple. It's not that hard at all. Here's what they're going to tell you to do. They're going to tell you to solve for x. All right, so you got to see the relationship. You got two parallel lines. You got a transversal. Is the relationship, Nico, you said it. What's the relationship between these two angles right here? Are they? They're supplementary, aren't they? Okay, now we don't have it because they're not all interior. 85 is an exterior angle, isn't it? Because it's outside the two parallel lines. So there's not a direct relationship between this, but you could do this. Watch, if this is 85, what's this angle right here? That's 85 as well. Now there's a direct relationship between this one and this one. Give me the name. Consecutive interior angles. Okay, they're interior angles. Do you see it? They're consecutive interior angles because they're on the same side of the transversal. All right. Again, I told you this yesterday, but the book I used to teach out of a long time ago would call these same side interior angles. I kind of like that better, don't you? It kind of explains it more. Same side because they're on the same side of the what? Of the transversal, right? And they're interior angles. Doesn't that make more sense? I kind of like that. But the book says consecutive interior, so we'll stick with what the book says. Now, what's true about that? Are they equal to each other? No. What's consecutive interior angles? They are what? Supplementary. So what do I do with these two angles? I don't set them equal. That's right. I add them up. I'm not going to do all the math. I'll let you do that on your own. You add them up, right? And you set them equal to 180 because they're supplementary. You can do the math if you want. I think you get 56. All right? You can have the fun and figure it out. Does that make any sense? All right. That's pretty much it. Let's go through one more little theorem and we'll be done. All right, this one's pretty simple. Watch this. If you have two parallel lines, right here and right here, and watch, if you have a line that's perpendicular to one of those parallel lines, let's mark these lines parallel. If you have one line that is perpendicular to one of these parallel lines, what do you think it's going to be if I continue this line all the way through here? What do you think it's going to be to the other parallel line? It's going to be perpendicular to that as well. All right, and let's look at it and let's think of a reason. Actually, let's go all the way through. All right. So look, if it's perpendicular to one of the parallel lines, it's going to be perpendicular to the other one as well. Why do you think that's true? Why do you think this angle will equal this angle if these are parallel lines? Because they're what? What's the relationship between this angle right here and this angle right here? What are they? Well, they're right angles, but something we just talked about. They're corresponding angles. That's right. They're corresponding angles. And what's true about corresponding angles? They're congruent to each other. Okay, so if this is 90, then this has to be 90. According to what? According to the postulate that says corresponding angles are congruent. Does that make sense? That's kind of like a little mini proof. This is a theorem, and we got it. It all comes back to that corresponding angle postulate, doesn't it? All right, so that's the reason right there. And that's about it. Yes, sir. Yeah. All right. Here's your assignment. So obviously it's section 3.2. It's going to be pages. Where am I? Is that right? Oh yeah, that's it. Angles of parallel lines. I'm sorry. Just looking at the wrong thing. 181, 182, 11 to 29. Alright, so that's your homework right there. Alright, have fun with that.